show the vertical translation of the sine and cosine curves. In our last investigation of the graphs of sine and cosine curves, we will see what happens to the graph when some constant d is added to the function. So these are our 10.4 notes. Okay, so the first thing I'm going to do, like I've been doing on the previous lessons, is I'm going to graph the function prior to the shift. Okay, so my blue function that I'm going to put right now is right here. Okay. So what I happen to have in blue is this function here. The graph of y equals the sine of 2x minus pi over 2. Now I'm going to show you what y equals the sine of 2x minus pi over 2 plus 2 is going to look like. So as I graph this, in red is y equals the sine of 2x minus 2 plus 2. So some of the things we might want to identify from my function in red is the amplitude. Again, the amplitude is the number in front of the word sine or cosine. Okay, that's being multiplied to it there. So our amplitude is the absolute value of 1, so it's going to be 1. Our period length. So I want to know how long this graph is. Well, it looks like it starts at pi over 4, and it ends here at 5 pi over 4. So the difference between 5 pi over 4 and pi over 4 is pi. Now, if you recall phase shift from the last section, it was how far the graph was either shifted left or right from our x value of 0. If we see here, our graph starts at pi over 4. That means the phase shift is a positive pi over 4. If we're given the equation up here, we know we could have determined the phase shift by setting whatever is in parentheses equal to 0. So our phase shift would have been 2x minus pi over 2 equals 0. Add pi over 2 to both sides. So we get 2x equals pi over 2. Divide both sides by 2. We get x equals, now pi over 2 divided by 2 is the same thing as pi over 2 times 1 over 2, which gives me pi over 4. So mathematically, beside the equation, I could have also determined the phase shift, or I can see from the picture. I just move this a little bit up here. As d is greater than 0, the basic sine graph shifts up, which is probably what we would have expected based on some of our knowledge of algebra 2. Okay, so that's my first one for our sine function. I'm going to now look at our cosine function here. All right, so what I have in blue here is the graph of y equals the cosine of 1/2 x plus pi over 2. I'm going to show you in red this function here. Y equals the cosine of 1/2 x plus pi over 2 minus 3. Okay, so I'm going to sketch this up here so you guys can see that. So in red, I have now graphed y equals the cosine of 1/2 x plus pi over 2 minus 3. Now looking at our equation in red, some of the things that we may want to consider are amplitude, the absolute value of A. Absolute value of 1 is 1. The period length. Okay, how long this graph is? Well, it starts at negative pi, and it travels all the way to positive 3 pi. So if I think about the length of this graph, it's as long as 4 pi. So the period length is 4 pi. My phase shift, you know we can do it mathematically using the stuff in parentheses, but if I look at it graphically, the first point here is at negative pi for the x. So our phase shift is negative pi. As probably predicted, as d is less than 0, the basic cosine graph shifts down. Okay, let's take a look at the next page. The process of moving a graph up or down is called vertical translation. In general, if y equals a times the sine of bx minus c plus d, or y equals a times the cosine of bx minus c plus d, then the vertical shift is equal to d. And this is the final one that we're going to look at for sine and cosine. So again, we can look at these general procedures here. Graphing the function without d is what I would recommend. So I'm going to actually have two graphs on our graph here. One without the vertical translation and one with everything taken into consideration. Alright, so what we're going to do, let's identify some of our values. So I know A equals 3, B equals 1/2, C equals that pi over 2, and D equals negative 3. Alright, amplitude, absolute value of A. So absolute value of 3, 3. Period length, 2 pi over B. So I'm going to take 2 pi divided by 1/2, which we know is going to give us 4 pi. Quartile length, you take whatever you got there, divide by 4, so you're going to get pi. Phase shift. Phase shift is the new stuff that we just learned in the last section. Okay, so I'm going to call that PS down here. To determine the phase shift, you're going to take whatever is in parentheses and set it equal to 0. So for this, I'm going to multiply everything by 2 to clear the fractions. So I get left with x plus pi equals 0. So x is going to give us negative pi. Alright, great. So my phase shift is negative pi. My vertical shift, hopefully I can probably identify that here as negative 2. Okay, so this is my sign. So I go intercept, max, intercept, min, intercept. Okay, and my points. Now my x coordinate, I'm going to look at my phase shift starts at negative pi, so that's where my first point is. And then I take this negative pi and add the quartiles. So negative pi plus pi is 0. 0 plus pi is pi. Pi plus pi is 2 pi. 2 pi plus pi is 3 pi. Now, the phase shift. I kind of like doing on the right side of these points. So I know typically my intercepts give me a y coordinate of 0. My maximum, because of the amplitude, would be 3. And my minimum would be negative 3. But now I have this vertical shift of negative 2. So all these points, I'm going to subtract negative 2 from. And that'll help me do the points of 0 minus 2, which is negative 2. 3 minus 2, which is 1. 0 minus 2, which is negative 2. Negative 3 minus 2, negative 5. And 0 minus 2 is negative 2. So we could graph both functions here, okay, if we wanted to do the initial before the vertical shift, which would have been -0, 0, 3, pi, 0, 2 pi, -3, and 3 pi would have been at 0. Now this is without the vertical shift. So what I have in blue here is 3 times the sine of 1/2 x plus pi over 2. But with that vertical shift, my final graph all got shifted down 2. So my final answer is really going to look like what I have in red here. So -pi, -2, 0, 1, pi, -2, 2 pi, -5, and 3 pi, -2. So what my final graph is in red here. So if it helps to do the blue and then graph the red, or you might just want to go right to the red, okay, by doing these pink things here. All right, let's look at the next example. All right, as I run through this one, I might go a little bit quicker. I know my A value is 1. B is 1/2. My C I know is part of my phase shift, but I know my D is +2. Amplitude, absolute value of A. Absolute value of 1, 1. Period length is 2 pi divided by B. So 2 pi divided by 1/2 is 2 pi times 2 over 1. So period length of 4 pi. Quartile length, whatever that is, divided by 4, which is pi. My phase shift now. Phase shift, I set whatever's in parentheses, okay, equal to 0. So if I subtract pi, I get 1/2 x equals -pi. I multiply both sides by 2, and I get x equals -2 pi. So my phase shift, -2 pi. My vertical comes from that +2. Now, right now, we're dealing with this cosine function. So I know it goes max, intercept, min, intercept, max. All right, if I look at these critical points, my phase shift is my first x coordinate. And then this phase shift is -2 pi. I'm going to add the quartile. -2 pi plus pi, -1 pi. -pi plus pi, 0. 0 plus pi, 1 pi. 1 pi plus 1 pi, 2 pi. So I know my x coordinates. Now, typically, I know my y coordinates for intercepts are 0. The max, based on this quartile, is 1. And the min would be -1. But now this 2, I need to add 2 to both of those. Or to all of those, excuse me. So now I have a new y value of 1 plus 2, 3. 0 plus 2, 2. -1 plus 2, 1. 0 plus 2, 2. 2 pi, 0 plus 2 gives me 3. So now I'm just going to graph my final function in red. So I've got -2 pi and 3. -pi and 2. 0 and 1. Pi and 2. 2 pi and 3. Okay, so there's my final graph in red of y equals the cosine of 1/2 x plus pi plus 2.